Hello and welcome. I do hope you are having a marvelous day. And we appreciate that you could join us. And today, I really mean we. But I'm your host, Charles Collegy, a security analyst for Accelerated Strategies Group. Now, today's DevOps.com webinar is brought to you by Armory. And today's webinar is Earnin's journey to secured and continuous delivery systems. And it's a panel. But I have with me Adam Lefkowitz. I said it in practice again, and I messed it again.
Hello, it's Adam Lefkowitz.
Lefkowitz, yes, Lefkowitz, who's the Customer Success Manager at Armory. Theo Salvo, a specialist for solutions architecture at AWS. Say hello, Theo. You must have stepped out for just a moment. Seong Chang, software engineer at Earnin.
Hello.
And Vivek Balaguru, who is a senior DevOps engineer at Earnin. And I forgot to say that Seong is a software engineer.
Hi, I'm Vivek.
All right, well, welcome, guys. And I'm sure you're eager to talk about how Earnin's small but mighty team migrated all of their applications, microservices, and pipelines in just a few months. And you did so working together with Armory and AWS. However, before we start the presentation, I must take a few moments to handle the housekeeping items. Now, please note that this webinar is being recorded so that it will be available on demand. Now, you will receive an email with a link, but at any time you can go to devops.com and gain access to this and all of the archived on-demand webinars we have available. So feel free to peruse our webinar library. Now, a few comments on the big marker platform we use. Now, on the right-hand side of the screen, you will see the chat button. This feature allows everyone online to interact during today's event. Say hello. Let us know where you're from. Feel free to provide any comments and give us immediate feedback. We want to hear from you. Now, for the questions, I ask that you do not use the chat. Sometimes questions can be lost as the chat continues to scroll as people fill it up. So I do ask that you use the Q&A window, which can be accessed directly to the chat. So there's a Q&A tab right to the right of the chat tab. And we'll try to answer as many of your submitted questions as possible before the end of today's session. And if we're not able to get to them, I'm sure Armory will follow up. Lastly, you will see the handouts button. There you'll be able to download additional information from Armory and our other companies here. Now, the most important housekeeping item is at the end of today's webinar, we will be awarding 4 $25 Amazon gift cards. So please stay with us until the end to see if you are selected. So now it's time to jump in today's session with Adam, Theo, Seong, and Vivek. Now, I'm not a referee, so guys, this is not a battle royal. Now, the floor is yours, Adam, so take it away.
All right, thanks a lot, Charles. My name is Adam Lefkowitz. I'm a customer success manager here at Armory. And Armory helps companies unlock innovation through our continuous delivery platform. And as a customer success manager, I've been supporting Earnin. And I'm really excited to be here today with you because not only has the team that I've been working with done some really interesting things with their SDLC, but Earnin also helps people build, financial success to, do things like avoid overdrafts, pay their bills on time, and really build a better financial habits because their app helps them access pay that they've already earned instead of waiting for, their paycheck, 2 weeks later. So it's pretty cool. So today, as Charles kind of introduced, we're going to have a discussion around how the team at Earnin, approach migrating from a monolithic app to containers, utilizing Kubernetes, with a focus on how they leveraged Armory and AWS to do that. Some of the key takeaways from the webinar today are going to be, why it's important to increase visibility for teams to manage services effectively. The strength of different deployment strategies, such as one-click rollbacks or blue-green deployments, why being fully modularized with deployment as code matters, and how to use various Helm charts to support different pipeline use cases that you may have at your organization. So let's go ahead. We're going to start with a presentation, and before that, I'd like to do just kind of a quick intro and then turn it over to the team here. Afterwards, as Charles mentioned, we should have some time for Q&A, so submit those questions and we'll see if we can answer them here live. So from the Earnin side, we have Vivek Balaguru and Song Chang, and then from the AWS side, we have Theo Salvo. So I'm going to go ahead and turn it over to them to start with the presentation.
Thank you, Adam, for the introduction and getting started here. And we will get into Earnin's journey to secure and continuous delivery system. Welcome all the viewers here. So before we go in, Adam started with Earnin. So I will also start with what we do in Earnin actually. Earnin's mission is to build a financial system that works for all the people actually. That's our mission. And the challenge that we have in the current financial system is that billions of dollars of wages are held between pay cycles, so employees don't get access to the wages right away. And there is high overdraft fees actually in the financial system. Actually, people pay money and it's really huge. That's what billions of dollars, as you see from the Forbes article. And it's also difficult to get credit if you don't have a good credit history actually, right? And then if you get a loan, and a credit, that basically there's high interest that comes with it actually. So that's where Earnin comes in, where we build a system that works for all the people, irrespective of what your credit history is and who you are. And we have access to the earned wages so that they could access the money whenever they want based on the working hours. And we also protect community members from overdraft fees and many more actually. So that's about Earnin. So now we go into the presentation of our CI/CD, the main topic for the webinar. So why we are here actually. So before we go into the presentation, how we solved it, I wanted to present the challenges we had so that you understand where we come from, and we present it here so that many of you might have it and this could help you actually. So the challenges we had as DevOps team is that we didn't have a DevOps team like a year or two back, and then that has to be formulated here. And that came into the picture. And we had an open source Terraform infrastructure, and it solved some problems, but there are issues with it, like when we had to maintain state between the AWS infrastructure due to the way the codes were merged without applying. So there are issues with that. And DevOps as a team, when we come in, we bring in standardization across the organization so that we have a framework in place so that everyone could use that actually. So that's DevOps standardization, very key part in this thing. So that was missing actually. And then we had so many tools, right? Once we don't have a standard in place, like there were so many tools, and I think this is quite common in many places actually. And then we had a monolithic system that was based on in-house deployment setup that we had. And for microservices, we basically used Jenkins to do a kubectl apply, and it comes with some of the challenges actually. And then there was no real visibility for the full pipeline as such actually. So you have to go through hop into here and there to see whether your deployment went through actually. And then all the deployments were not automatic. Like we had to do some manual deployments using our SRE team. And then if you do manual deployments, you have to do manual rollbacks, right? So it was not like a complete hands-free deployment that we had. And then we didn't have fine-grained access to the deployments, like who can do a part of a deployment and all. It was like kind of a bit open deployment model that we had actually. So having all these issues, we had to work on a solution. So we put our minds together and evolved, and this is what we came out with. These are the 4 pillars of our infrastructure now, what we have for CI/CD actually, right? So in these 4 pillars that we have, I will go over the first part, the key part where our foundation is based on, right? So we talk about microservice and Kubernetes. So we standardized on Amazon EKS, and we work very closely with AWS, and they have been actively helping us. And we have migrated all the microservices here, and it has helped us actually in this journey. Actually, helped us a lot in this journey. And I touched upon Terraform as an open source platform, and some of the issues that we have. We also have Terraform Enterprise, so that the infrastructure as a code is in place. And then basically it helps of setting up the EKS clusters and roles and policies, whatnot, secrets by managed by Terraform Enterprise. And you have infrastructure as a code with that actually. And we have GitHub as the source control, and then we have standardizing on GitHub Actions as a CA tool going forward actually, because it's close to our source control and it's started well actually. And the final and the important piece of this CD is that Armory helping us roll out Spinnaker actually, and that has been the story that we are going to go more into it, how we did and what we are going to do actually. So, but basically these are the main pillars of the our architecture. Now, what does Armory did with us with Spinnaker that brings us the CD actually, right? So what are that we had and how we solved it and how we worked, right? So this will be the highlights, I would say. So let's go to the ones. Dingy modules is a term that people who are not used Spinnaker or might be new, but you know pipelines as a code. If you use Jenkins, you would have used Groovy pipelines as a code, and Terraform is like pipelines. So similar to that, we have a Dingy modules that we have in Spinnaker, and basically what it is like it's like brings us to maintain history and pipeline code along with the source code for developers actually, right? And what it does is that other than all these things, like the it avoids a steep learning curve for a developers when you onboard them to Spinnaker UI. There is like you introduce a new tool, you have to learn everything. But since we did this as a code, they just have to begin migrating their application by just modifying some values to variables, Helm chart types, and pipeline, and then they could use it actually. So that has really helped us actually. So that is one thing I would say one of the highlights of the Spinnaker that is a lot. And then there is this real UI. As I said, the challenges we had is like when you do a microservice, right? You do a kubectl deploy, and then you need to know what's going to your Kubernetes cluster, kubectl pods, and all that stuff. A view of what is going on in the pod, and at the same time looking at the logs, what it is. And we have that UI that comes with Spinnaker that you have this full pipeline of the pipeline, what's going on in the pipeline, what's happening in the pod level with the log level, and those things are very well captured in one, so that it makes the an engineer need not know all the Kubernetes skill set to understand what's going on. It makes it easier for him actually, right? So you could relate to this in your own organization, how it is actually if you give that. And then one step further, like we have Datadog is our observability platform, and then it helps enhancing the logging and integration with Datadog. Um, I will go deep into it when I go to Canary analysis and when we do analytics. This really helps actually, so that we really know what we are deploying. The analytics part tells us like the metrics that is involved in this one, and then it helps you there actually. So that's the deep integration work. And then key point in this whole thing is this deploy times, right? It's a no-brainer. Like on an average, I'm talking on an average, we had 3x improvement, but in some cases, critical cases, it was more than 10 actually, right? So I don't have to go deep on like what it gives like when you improve the speed at which you deploy, right? So what is used to be like a 5 minute becomes like what used to be 15 minutes becomes 5 minutes. You can see the smile in the developers that he can go and do other things that improves the productivity there actually straight away. And also key is that when we do migrations, right, and when we show engineers this new tool that we are rolling it out and they see this difference, it's easier to convince them to use them, right? There is no, they became your champion actually. And then Spinnaker provides this one-click rollbacks where you can go and then you can provide the rollback as fast as you could actually only. And then the extension of the deployment, the one more challenge we had was all or nothing deployment, where you go and if something fails, you have to roll back. We have this red black, which comes with Spinnaker. and you go and deploy one set and see if it's stable, then switch the traffic to the new one, keep the one, and if something happens, you can roll back actually, right? So that is red black, we rolled it out. And then we are adding Canary analysis on top of that, so that to make the deployment much more controlled actually, and also better. So we did this with the small DevOps team, like two of us are here, four, we have two more people in the team. So we have 4 people supporting more than 100 engineers. So basically we have 2 monoliths and then 40 plus microservices with 80 pipelines. We started this in a quarter, and then we understood, and then we migrated in the next quarter actually. So now, how did we migrate this, right? So we have a framework, a platform in place. We know what we are going to do, what Spinnaker brings. How do we do this with what we have internally, right? So this is always a challenge when you migrate anything in software. So this is how it worked for us actually. So we picked up the core services. The core services can be standalone by themselves, that they give you a functionality of product that people could use. So we picked them up. Initially, we started with the manual pipeline so that we were also learning as a DevOps as a team, and we bring in new engineers. So we kept the manual pipelines and slowly moving to the modular. And then the stage one was the fundamental part of a product. We picked them that brings the core of the microservices and rolled it out. We saw how it is, and we started fixing things, what is good, and we understood Spinnaker better. We understood the flow of to use for our services. And then stage two, we picked all the dependent services that are dependent on the basic services depends on, so that add more value to that. And when some of the challenges we see were like, as like any other software organization, there will be more than one language by which applications develop. So you have to make sure that your pipeline takes care of that, including the components, how they are built, how they are tested, so that pipeline can have this flow in this actually, right? And then we took that as a second step. And then as part of the third step is where we, as I said, there is a monolithic service that is running on EC2 instances. And we have to bring it in, and it depended on both the stage 1 and stage 2 services. Actually, it was a bit challenging, but we got that as part of the stage 3. And stage 4 is this, when you bring everything together. Like we had some services as part of the Kubernetes where it's not only a web app, they were processes, they were cron jobs as part of that service. And so we kept them as the end so that we understand all this well, and then we brought them in actually. So that basically completes our migration stages actually. Now, a bit deeper dive, I would like to hand over to Song. Song is the in-house Spinnaker expert actually. So he did most of the work understanding Spinnaker and how to deploy and all the stuff. He set up the basic thing for us, and I would like to hand it over to Song. So,
thanks, Vivek. Hello, my name is Song, and as mentioned, I'm one of the software engineers here at Earnin, working with Vivek. Right now, we're gonna take a deeper dive into our CE, what it looks like from a code perspective, and also from the Spinnaker UI perspective. So when we started out on this proof of concept journey, there were a couple things that we wanted to provide for the developers, and also for our team, platform team, and specifically for the DevOps team. One of the things that we wanted to provide the developers with was consistency, because we wanted to reduce confusion for developers as they set up their CI/CD pipelines. Reliability, because as they set up these CI/CD pipelines, we want to ensure them that their pipeline is going to deploy their app successfully. And if there is a problem, it shouldn't be a problem with the pipeline. It should be a problem with the applications. And third, repeatability. We want to provide the developers with tools that they can continually use to deploy not just one microservice, but many of them. But also for the DevOps team, we wanted to provide or ensure for ourselves some of these things. Number one being scalability. As mentioned before, we're a team of 4 supporting 100+ engineers. We need to ensure that we can support them to the quality that the company expects. Number 2, flexibility, because we want to meet the demands of the product and also the developers' needs, and we want to provide them with enough tools to innovate within their tech stack. Number three, standardization, because we need logging, we need APM/monitoring, we need organization and quality in our applications. And lastly, not the least, security, because we need to ensure that our app is performing only what it needs to do within our environment, within our infrastructure. And also, really important, we need to protect our customers and also engineers from what they're not intending to do. And so with those things in mind, we want our solution for CD was a combination of Helm and Armory Spinnaker. To quickly define what they are, as most of you guys know, Helm is a package manager for Kubernetes, and Armory Spinnaker is a different flavor of Spinnaker that Armory provides. And specifically, I put the word Dini here because that is one of the features that Armory provides specifically. And it is the microservice amongst many other microservices, if you deploy it, that provide code as pipeline feature. And as I'll talk about momentarily, Dini was one of the key features that we were looking for in our CD solution. So looking at our repository, at a high level, we wanted the developers to take ownership of their apps. This is including their CI and also their CD. We wanted the developers to, we wanted developer-related code inside source control so that we don't have to look anywhere else to dig where is our pipeline defined or how are deployments defined. We wanted all of that within the microservice repository. And once again, Helm and Dini provided us what we want. As we can see in the slide, our CD structure with Helm and Dini allowed us to make it very nice and clean. There's only Helm and Dini. And one thing to note here is that the Dini file is it's the file that Dini microservice looks for every time you merge code to write or to define your pipeline as code. And we will see later that we'll see the contents of the Dini file, but also we'll see how that Dini file translates into the UI. Before going into Dini, let me talk quickly about Helm. We use Helm 3 mainly as our manifest render, and then we have Spinnaker do all the deploying. So it works hand to hand. And using these Helm charts, it allowed us to standardize across all of our environments, across all of our applications, and still provide, because we're using Helm chart, we still want to provide engineers with ad hoc configuration ability so that they can inject whatever they need to do to run their pipeline or deploy their applications. And because we've standardized in this way with the file and Helm, it allowed us to be ready to roll out the changes from security teams, platform teams, and site reliability teams in the case that we need to make an urgent deploy that all of the applications need to apply to. And that's it for Helm. Now looking at the Dini file. So this code snippet that you see here is part of the Dini file. We have another section that will display the other half. But as mentioned before, Dini file helps us with writing Spinnaker pipeline as code. And what this meant for us, to reiterate, is that we can, this meant that any repository is a single source of truth for each application, from application perspective to the CI to CD. And here is the CD part. So again, for us, this meant that if we can deploy a microservice, let's say microservice A, with a specific Helm chart and a specific Dini module we'll talk about in a second, but this meant that if we can do that, then we can follow the same convention for every other microservice. And The reason for this is that we want developers to develop. We want developers to innovate instead of being bogged down by the complexity of CI/CD. And as you'll see later, our stages are somewhat complex. The one we'll show is not the most complex one, but there are cases for more complex pipelines. But because we're using these modules, we can continue to reuse them as templates or modules so that developers don't have to get confused and wonder what they have to use. And one of the nice things about defining your pipeline, your CD pipeline as code, is that, let's say, I'll use Vivek here. Let's say he comes in, makes a ad hoc or a manual change from the UI, and then that works for that particular run. But let's say I come in and I submit a new code. What happens is that DINI file will always look at DINI will always look at the DINI file as the source of truth, and whatever change you make manually on the UI, it will be overwritten. Although that might sound like, oh, like we don't want that, but one of the advantages that we get is that if someone we can always look at the repository, especially the Helm files and the DINI file, to be the source of truth. And that's where all of our changes should go in. And this ensures that, hey, if it's not in code, it's all fair game. And from a DevOps perspective, we don't need to keep track of the pipelines in our memory, but rather go to the code itself. And that's where we know what we exactly have today. And going further into the DINI file, here we have the main core part of the DINI file. One thing to note here in line 46, line 52, and 53 is that we heavily utilize modules at Earnin. To explain briefly, the JSON representation of the Spinnaker pipeline is a lot longer than what you would have in a typical DINI file, especially if you use modules. And we extensively use modules to save some time and also give the developers decision as to which pipeline process they want to use. Sometimes they want to deploy a web app, sometimes they want to use processors, or they want to deploy only cron jobs. So we want to provide the developers with those tools to deploy, and they don't have to think about the complexity of the CD aspect. And to give you perspective, again, like how much time the developers are saving, if for this example that I'm showing you, it's actually about 80 to 90 lines of code or JSON. If you go into the Spinnaker UI, if you choose to define your own JSON, for this particular example, it's about 850 lines of code to 900, and that's pretty consistent through all of our applications. And whether you go that route or if you go to the manual route, as you'll see momentarily, our pipelines are pretty complex. It's very unlikely that it will save developers time in defining their code. And so we've defined what our CD looks like from a code perspective. Now we're going into the UI to take a look what they define. And we have a lot of other features that we wanted to share, but for the sake of time, I picked out a handful of them. One of them being the pipeline as code and the manual judgment to production, and lastly, one-click rollback, as Vivek mentioned earlier. So from the code snippet that you just saw, what that translates to is this, what you see here. You see a bunch of green boxes, you see some gray boxes. Let me break this down a little bit for you. At a high level, this breaks down into different environments. First one being dev, second one being stage, and the last one being production. And the way we've broken out our DINI modules is, through environments. And you'll see if you read the names of these stages, you notice that it's pretty consistent. You bake the manifest, you deploy it to whichever environment, and then we do a red-black deployment process. And if it fails, we have an automatic rollback. But if it succeeds, we go to the next environment, making sure to clean up our previous deployments and so forth. Let's see. One thing to mention here is that we do bake in our in-house system tests and smoke tests, which is currently grayed out in the box there, but that's what it's for. And as we go along the pipeline, you'll see that there is an orange box to the right. And that is actually the step right before it goes to production. And as I show you here, it's a manual judgment stage. So even though our deployment process for every environment is similar from dev to stage to prod, we wanted to give granular control in our production environment because it is production. Today, we include this manual judgment stage that halts the pipeline. It doesn't terminate it, but it halts it so that it gives the developers some time to make a decision going into production. And it is at this point that owners of this microservice, they make a conscious decision to deploy their latest code into production. And once they continue, it will deploy to production and do the red black deployment. If you choose not, it will terminate then. Let's say in the case that we do decide to continue, we also add another feature, which is the one-click rollback. So previously, we had a solution that with Jenkins that had a very complex way of rolling back, and it wasn't straightforward for the developers. And actually, for the developers, when they had to roll back, it was forward rollback, not a true rollback. And so here we added this stage, another manual judgment to give the developers another option to roll back after they deploy to production. And the reasons for this there are many. One of which I can share now is that if the app isn't performing to the quality or to the level that the developers want from an APM perspective, they can come here, let the deployment bake in a little bit, look at the charts, and make a conscious decision to roll back even though you've deployed it to production. And in this way, the rollbacks are very easy and intuitive. One of the things that, actually, yeah, that's it. And let's say in the case that the developer wants to roll back, what happens in the background, and one of the nice things that Spinnaker does is that there is a view from a clusters view. If you go to the UI, you can see the current state of your deployment. So let's say for this example, you're on version 2 of the replica set. That was already there, and we deployed this pipeline. What happens is that Spinnaker will create a new replica set with the new image, and it will be running on version 3. One thing to note here is that on the left side, we were currently on version 2. We deploy version 3 in a red black deployment process. What we do is we make sure that traffic is no longer pointing to version 2, but it is pointing to version 3. And let's say we bake in for a couple minutes and we decide that we need to roll back because it's not performing well. You make that manual judgment, one-click rollback. What happens is the traffic will switch back to version 2, which is already running. We haven't deleted them. After you switch the traffic, we do some cleanup, meaning we scale down the version 3 replica set, and then we safely discard that. And that's what it looks like after you do a proper one-click rollback here at Earnin. And that is it. Thank you for following and sticking with me throughout the deeper dive. And I'm going to hand it back to Vivek to talk a little bit more about Canary pipeline, which I've not discussed, and our closing thoughts.
Thanks, Song, for taking deeper into the code part of Dingy and Helm, actually. It looks like maybe a bit complicated, but it is like within like few days, I think. Since we all are used to Helm in some form of YAML and all these files, like it should not be that hard, actually, just to give you that, but really help, actually. So now I'll just touch upon certain things which we talked about. So the Song showed up a pipeline, which was like the basic one that has everything. I also talked about the Canary pipeline. So it is slightly different, and this adds more value, right? So you want to give a pipeline and give a confidence that this package that you're going to deploy has passed all the tests, or the metrics is really good, and then you're confident like deploying, it's a no-brainer to deploy because it's not going to fail because you have the data in hand before it. With a simple set of deployment, you know what it is. So that's where this Canary comes in. So in the Canary, you see that what we basically do in Canary is that we have a baseline pod, in this case, in a microservice. Baseline pod is nothing but a pod that is going to run with the version that is already in production. And Canary deploys a pod that's going to run in a new version, right? So if you see that we have a find artifact step, which basically finds you the version that's already running and giving you a baseline deployment. And then you're going to deploy the Canary with the new version. And then once you compare them, a Canary analysis on this, you pretty much know what is the delta, what is the issue before you roll out in a full-blown deployment. Actually, that's basically this pipeline gives you that is different than the other standard pipelines that we have. But we are rolling this out to other things so that you have good control and we understand the deployments better. Now, the next slide is about our production deployments, what we have got based on what we have done. So basically, the first quarter is when we analyzed, we rolled it out slowly, and the second quarter, what you see is when the rollout is done. And you can, the chart speaks for itself, but I'll just go into certain details actually. The incidents during prod deploy really came down after of all this deploys that we did, of all the improvements we have done with what we have done actually. And we have migrated all the services, Spinnaker at this time. And then self-service deployments has continued to increase actually. And as you see from the charts actually, that the deployment rate has also picked up, like almost 50% then, more than what it was in the first quarter. And I would say we rolled out new services as well, but CD, the faster deployments, all the improvements we have done really help here actually. And now coming to the next slide. So the results, right? The results speaks for itself actually. So we have definitely increased our deploys, and deployment time has come down very well. Like as I said, the speed is 3x and 10x in some cases. Pipeline visibility, that's what is like. You have all the views there. You don't have engineers jumping here and there. Increases the productivity, right? So at the end of all these things is that how much time you gained out of this whole thing, right? The faster a PR goes from check-in to the production, that is when the real win is actually. You give the time back to the developer so that you could write more interesting features rather than debugging things which you might not fully understand actually, right? And make it much harder, make life harder for a typical engineer in a day actually. So that is basically what this gives us, so that your velocity rate increases. That is like, and then less rollbacks because of all these things that we have. There are less rollbacks to deal with, and given that we have all this automated and we have all these rules in place, now the deploys are not handled anymore. Engineers have the power to deploy themselves. They can go to the prod and deploy because of all the confidence we have. And it basically sets the engineers free. And not but least, we might not have touched more on it. We have SSO and RBAC enabled for the deployment so that we give permissions based on who can deploy what and what are the permissions they have in production. And we know what is going on in each pipeline, who presses in case of where there's a manual judgment to someone to press it, we know who it is. And we keep track of, if we wanted to see what all happened in like last 30 days, who all deployed, everything is available to us. And what's next, right? So we have everything, right? So it's the next what do you call next. Well, I think most of you would be here somewhere in CD, and now we are in the next quarter, like next game, next step in the game of CD. What the point that we are trying to say is that we have this fundamental framework or platform in place. Once you have that, whatever you build on top should be just like plugging it in. And we have seen that already. So we have two pieces coming in. We are rolling out AWS App Mesh as a service mesh for our services. And we didn't have to make much changes in what we have. That is a work in progress that is going on. And progressive CD. Progressive CD is the next evolution in the CD, where you control the traffic, how it is flowing. We are moving towards that step, and what we have done has helped us to have this step forward, help us in the next step of this journey actually. And that is what we have. And at this time, I think we are ready to take questions. And I think I've answered a couple of them, but if someone can facilitate the one with top votes, we can even go over them. Thank you. Thank you for listening to us so far.
All right, thanks, Song. Thanks, Vivek, for going through that. And thanks, everybody, for submitting some questions. So I'm just going to go ahead and see if we can get through some of these here live on the webinar. So the first one, a 25-to-1 ratio for developers to DevOps teams seems high. Do you feel that's an appropriate level? And I'm kind of going to add, is that kind of due to the strategy for the team, or kind of out of necessity in the organization?
So I think I answered that, but I'll reiterate that. It's an interesting question. Actually, it's pretty high actually. But DevOps, as a term, it comes at different flavors. But here we have a separate SRE, separate cloud ops who manages the infrastructure, and we as DevOps focus only on CI/CD actually. So basically, so that is our DevOps, and basically it is still high considering all this stuff. And then we work basically on the developer velocity, and then initially we do all these things, and that's where the migration comes. You gradually train your developers, right? So we have a group of services, and then you make your evangelist in engineers who understand this well, and they say, well, this really works. And then he becomes your evangelist in the engineering community and engineering thing, and then he will do most by himself. You set him free actually. So he would be like doing all these things. He knows Helm, he knows Dinghy, he knows how when he starts a service, he can guide other teams like, oh, this is very easy, I could help you guys, and then do it, and this way we are able to scale actually. That is how I would put that. Yeah. Anyone else have any thoughts on that?
I can speak a little bit on that. Like at some point, you have so many examples of Dinghy files and Helm charts and Helm values that other repositories are using. People or engineers end up reusing some of those examples to save, time. Yeah.
Yeah, I think one of the important pieces that you talked about, Vivek, is having that evangelist or somebody that is kind of carrying that message forward is super important for any type of changes. So sounds good. All right. So maybe the next question is, how many times has there been a choice to stop the production deployment? And was that a coding issue or a business decision to stop it from going forward?
So this is like, see, this is where the production deployment, this is where Canary comes in, right? So we rolled out Canary for sensitive deployments, right? Like some things which you cannot have like a second of downtime, right? And then that basically the Canary, when it runs, it basically gives out you the data that you need, and then it will tell if there are bugs that didn't been captured during your process of CD, like your unit test and the stress and all the stuff. That basically will tell you, wow, this is not supposed to roll out. So you basically expose the analytics to the engineers by itself. So basically it stops the production deployment. That is, I would say, the ideal situation, and we are making that happen actually. I would say that is the one thing which has stopped deployment, because they've seen this diff and then say, oh, that is something which we missed actually. And Canary helps, right? So where does Canary help is that you can have your dev, you have your stage, but production, there is always a delta where there is slight difference, and Canary will help you reduce that gap, and then help you there to make the decision if it's definitely going to be an issue there. Actually, that is how I would put it for that.
Yeah, and Vivek, would you say that the Canary capabilities kind of catch a lot of the technical issues, but then, I know that you do have a manual, essentially manual judgment stage in there to maybe address some of the business decisions. Is that pretty fair to say? That you have, kind of both of those steps in.
Yeah. So business decisions, where it comes is that certain times of day, you have certain features of functionality that there is a traffic at particular part of time, right? And then you want to not do that at that time because you don't want to like hit the traffic and you want to make a change during that time, that is when that comes in, and then you schedule that later on actually.
Yeah, I think maybe a follow-up question for me is, when we talked about technical business decisions, but security is obviously an important choice. Is that how do you kind of handle some of those things, and from a security perspective, make sure that things are being deployed appropriately?
It is like so security. When we talk about security, it comes from ground up actually, right? I think there are like 3 or 4 questions I could answer with this one question actually. So someone brought in this question like, how are you scanning the code, right? So when you say talk about, you have to start from where the code is checking, scanning, right? So we are using JFrog Artifactory for binary repository, and they have a X-ray for binary and artifact scanning. It starts from there, right? That's the first level of scanning. And then we have other tools as CodeQL and SonarQube to do that as well. So that is the first level of thing. Then second level, that's where someone, there was this Terraform state question that came actually. I could try to answer it now. So Terraform, basically you have that when we set it up, like you can have Terraform enterprises that you have Sentinel rules that you can put it inside so that people cannot break certain rules. Like you have security groups that you have, this is what security groups, you cannot break in that. If you put a PR in with those rules, your PR is not it's going to fail actually, right? You cannot make the change. And that is what Terraform Enterprise Sentinel brings you, guardrails into that. So that is like second level. You have first level where code scan, second level where you have this guardrails, where you have all your basic rules covered in the Terraform Enterprise. We have dinghy modules. We have all this covers what we do. And basically those are how we do. And then Spinnaker itself brings this RBAC and all these things, right? Like who can do what, right? It's like a person does not, like, we know who is going to deploy and who is going to make the choices. So that is like, I would say 3 or 4 levels of layers of security that has to be baked. You cannot get that at one level actually. So it has to be done at all different levels.
Yeah, thanks for answering that. I think what we've seen is companies all want to move faster, but there's these guardrails, as you said, that need to be in place in order to enable the organization to do that as well. So, all right, thanks. So we've got another question around how do you enforce standards across all applications, or do you for the enterprise?
So it is a bit tricky actually, right? So when you have enterprise, the standards, you need standards because that is when you have to have a fine balance between standards and freedom for engineers to do things. Actually, it's a fine line you have to do, but I would say DevOps as a team, when you do standards, is key actually. So standards, how do you implement in an organization, is that you show the added value, right? So if let us say you work on, like, your team, you have only 2 or 3 services, right? And then you want to onboard certain people in your team. A new engineer comes in, and then you can only look at your application service. DevOps needs to come in and help you in deployment. You need to be consistent with the standards, right? Only then they can help you. Otherwise, they won't be able to help you. So the standards, if you really want to scale and then you wanted to like just focus on your domain, the standards really help actually. So this is basically how it has to be like evolved in an organization, so that when they see that, they see, wow, it really saves time. I don't have to do all this stuff because the standards are there. If I follow this, I don't have to worry about deployment. I just work on my code part, and then I can focus on that stuff actually. And that is what I've seen in my experience basically. If anyone else wants to add, they can go ahead.
I can talk about an example. So we had a team that every time they try to deploy something, it would take about 30 minutes. And we gave them, we helped them set up their CD pipeline. And they saw their application go from dev to production in less than 30 minutes. And if you show the engineers, I guess, results or how much time they're saving, like Vivek mentioned earlier, they wouldn't have a problem adhering to some of the standardization that we are requesting the teams to follow, so that we can better help not just debug, but deploy faster. So yeah, that's just another example that I wanted to talk about.
All right, great. Yeah, I think one of the things you talked about, Song, is really, the goal of the team was to, if there is an incident or, some kind of failure, it's at the application, right? And instead of the pipeline. And if you can, build that trust with your, developers, I think, like you said, they're probably much more willing to, follow a standard or something like that. So. All right, cool. So we've got another question. It's a bit long. Let me know if you want me to kind of repeat it here. So can you go into more detail about the problem with Terraform state, why you had the problem and what you were needing to do specifically that Terraform could not do well, and then how it was solved in the new tooling. It seems that Spinnaker red black only works with replica sets and rollbacks only work with deployments. So if doing red black, can you actually do a rollback?
I can talk about this. Two different things. One of the things that Vivek mentioned, I think, was we utilize AWS for our secrets, and we do define them through Terraform. Although so I forget when it got introduced, but currently, if you create secrets through a Terraform Enterprise, there is a way to hide the credentials, which is the key reason why we're doing that. So that's required as apps are deploying and they need to fetch some secrets from Secrets Manager in AWS. On the other hand, this question about red-black deployments, and I didn't spend too much time on this one during the slide, but the way that Spinnaker does their red-black deployments is through replica sets, as mentioned in the question. It's different from the Kubernetes rollout strategy in the sense that red black will deploy version A, and then let's say the version A exists, and then you deploy another one, it will come as version B, and there is a traffic switch that happens through a match label from a pod perspective. And so that's how we do a shift in traffic. And it only does that when the replica sets or the pods that have come up with the new version are passing all the health checks, readiness pro, all that. Unless it is actually healthy from a pro perspective, it will not be a successful deploy. Traffic will not go to the new version. And the way we've set up is that we give a time frame for the deployments to succeed. And if it succeeds within that time frame, you can go ahead. But if it fails, then we do an automatic rollback to the previous version. And what that means is we're switching back the traffic to the previous version. Hopefully that made sense. If you have a little bit more question, maybe there's a doc on that.
And Song, if you would just to kind of follow up with that last part, so we're able to do a rollback even when we're doing red-black deployments?
Could you repeat that question again?
So if we're doing red-black deployments, we can still do a rollback with this solution?
Oh, yes, definitely. And a bunch of our applications are doing our rollback in this red-black strategy today with replica sets.
All right, so we got one last question. I know this is something that I'm assuming a lot of people are kind of interested in. Is have you been able to track the more frequent deployments to increase in profits or some other business KPI?
Productivity, right? So basically, engineering productivity, we are able to track like how we do is that. Basically, I think that is the key actually, like PRs, how many PRs comes from the productivity basically comes like how many PRs, it's basically engineer's life is like code and then how many PRs you do. And we are seeing that actually. And then I would say the PRs have increased over time because when you have your code going faster, you tend to write more code because you're not stuck on deployment actually. I would say that is one key thing actually, which I think anyone can measure that in their pipeline or in the cycle, where you see where what happened before and what happens now. And when you remove all the bottlenecks, the pipeline goes. It's like there's like you give a freeway rather than all the lanes they go faster actually. So that's basically one of the key takeaway that we can easily measure actually.
All right, thanks for that. So I think that's all the time we have for questions. I know that there's still a few that were there. Sorry we didn't get to them. Last announcement before we go into the drawing. Armory, AWS, and Earnin have kind of teamed up for a case study that should be coming out sometime about mid-August. So keep an eye out. It's going to have a little bit more details around this journey that the team went through and the organization as a whole in terms of doing this migration. And so let us know if when you get that email, keep an eye out for that to get more information from us and really for everybody here on the webinar. Thanks a lot for showing up and participating in the Q&A. Now we'll give it back over to Charles to do the drawings.
Well, thank you. Thank you, Adam. And that was some great information, guys. It's amazing you could accomplish so much with such a small team. You mentioned 25 to 1, so that's really makes things smooth. It sounded like I definitely picked up a few nuggets of information, and I'm going to have to read up on Dingy as pipeline as code. That was one area that hit my interest. But as Adam mentioned, it's now time for the announcement of the $25 Amazon gift card recipients. And so they are Wayne L., Kimberly M., Monique F., and Carla R. Now you will receive an email at the email address that you registered for this webinar with. And if you're like me and you have 7 email addresses, you need to check them all. The email will explain how to collect the gift. So don't forget to check your spam filter also if you do not receive it soon. I want to personally thank Adam, Theo, Seong, and Vivek, our sponsor Armory, and their partners Earnin and AWS, and you, our audience, for taking an hour out of your day to spend it with us. Goodbye, and may the fickle finger of fate be kind to you.